All right, geometry, we are wrapping up our unit on volume with a lesson about volume of composite figures. Composite figures are figures made up of multiple basic figures. So in our case, it could be made up of a cylinder and a cone, or a rectangular prism and a pyramid. So we are going to be able to take those composite figures and we are going to apply the volume formulas we know to find the volume of the total figure. So here are the volume formulas that you are going to need. The ones that we covered in our unit are the volumes of prisms, cylinders, pyramids, cones, and spheres. Remember that prisms and cylinders have a volume that is the area of the base times height. The volume of pyramids and cones have a volume of 1/3 the area of the base times height. And then spheres are a little different. The volume of a sphere is equal to 4/3 times pi times the radius of the sphere cubed. All right, jumping right in. A silo and its dimensions are shown. If the silo were completely hollow on the inside, how much animal feed could it be filled with? So the first thing we need to do when presented with a composite figure like this is to identify what are the basic figures here. So off to the side, just to keep myself organized, I'm going to identify what are the basic figures with volume formulas we know. So I'm seeing a cylinder, that's the base of the silo. So I'm seeing one cylinder, taking an inventory of what we have here. And then at the top, it's not a sphere, it's half of a sphere. And we call half of a sphere a hemisphere, kind of like the globe, how you have the southern and northern hemispheres. So this is one hemisphere, in other words, half of a sphere. So now that we know what we're working with, we are going to find the volumes of each part of this composite figure. So let's start with the cylinder. So I know that the volume of a cylinder equals the area of the base times the height. In other words, pi r squared times height. Let's clear up what we know about the dimensions of this figure before we get into this. So I know that the width of this silo is 2 meters, which means the diameter of the base of the cylinder and of the sphere is 2 meters. To find the radius, we're going to cut it in half. So the radius should be 1 meter. And likewise, the radius of the hemisphere is 1 meter. So now we know all the dimensions we need. So the volume of this cylinder is going to be pi, and I'm going to use 3.14 for pi, times the radius, which is 1 squared, times the height, which is 3 meters. And so when we multiply all of this together, and calculators are totally fine for this, if we multiply all of these terms together, we are going to get 9.42 cubic meters cubed. So the cylinder volume has been found. Now we need to go on to the hemisphere. I know for sure that the volume of a sphere is equal to 4/3 times pi times the radius cubed. But since we're working with a hemisphere, or half of a sphere, we're going to take that whole formula and multiply it by 1/2. Or you could divide it by 2, but then you'd have a fraction within a fraction. So the volume of this figure is going to be 1/2 times 4/3 times pi, and we're using 3.14, times the radius, which is 1 cubed. And when we multiply all of this together, we're going to get the volume is equal to 2.09 cubic meters. So we found the volume of both parts. Now we need to find the volume of the entire figure. We're going to add those volumes together. So the volume of the silo is equal to the volume of the cylinder, which is 9.42 meters cubed, plus the volume of the hemisphere, which is 2.09 meters cubed. So the volume of the entire silo, if we're completely hollow, would be 11.51 cubic meters. Let's try another one. So in this case, a cone-shaped hole is drilled into a prism, and it looks like we're dealing with a triangular prism here. The height of the triangular base is 12 centimeters. So we are asked to find the volume of the remaining figure. So first thing we need to do, just like before, is identify what are the figures we're dealing with. What are the basic figures? And so the problem already identified what those are for us. So the first one is the triangular prism. There's one of them. And it also said there is a cone drilled into that prism. So we're going to deal with that concept in a minute. What I need to know right now is that there is a cone in this figure that I'm going to need to find the volume of. So at the very end, what we're going to need to do, since the cone is drilled into the prism and we're trying to find the remaining volume, that gives me a hint that we are going to be subtracting the volume of that cone. So the volume of the total figure is going to be the volume of the triangular prism and taking away the volume of the cone. Volume of the figure equals the prism volume minus the cone volume. So let's start out by finding the volume of the prism. And since I don't have all of the measurements in the triangular prism, I'm going to redraw it just off to the side as well as I can. Okay, so I know that the base, finish drawing here. I know that the base is 22 centimeters. The height of the prism is 8 centimeters, and I'm told the height of the triangular base is 12 centimeters. So the height of the triangular base is 12 centimeters. I know that the volume of any prism is the area of its base times height. So the area of the base is going to be half times its base, which is 22, times its height, which is 12. And then we're going to multiply by the height of the actual prism. And when I calculate this, the volume of the triangular prism is 1,056 cubic centimeters. And so now we need to find the volume of the cone. Let me change up my color here. And I'm also going to redraw the cone because I want to make sure that the dimensions of this cone are absolutely clear. Okay, so the center of this cone is here. The height of the cone, it doesn't appear to be given. However, the cone is drilled completely through the prism. So the height of the cone should be the height of the prism, and that's 8 centimeters. And so the radius of this cone is given, and that is 3 centimeters. So to find the volume of any cone, the formula is 1/3 times the area of the base times height, or 1/3 times pi r squared times height. So our volume then would be 1/3 times 3.14 times the radius, 3, squared, times the height, 8. And when multiplied, that gives us a volume of 75.36 centimeters cubed. So now we have the volume of the triangular prism and the volume of the cone. And we are asked to find the remaining volume after we take away the volume of the cone. So let's fill in what we know. So the volume total is equal to the prism volume, which is 1056, minus the cone volume, which is 75.36. So the total volume is equal to 980.64 cubic centimeters. So the only difference between this problem and the previous problem is we had to take away the volume of one of the figures because we are finding the remaining volume of the composite figure. And I've got one more problem. This one has a lot of parts to it. So Caitlin is making a concrete animal sculpture. Each bag of concrete mix makes 0.6 cubic feet of concrete. How many bags of concrete mix does she need? All right, so in this problem especially, it's going to be important to identify what are the figures that we're dealing with. So there appear to be a lot. So let's work our way from top to bottom. So on the top, I'm seeing a yellow pyramid. And logically, I know this is a square pyramid because if it were triangular, it wouldn't be sitting upright. So this is one square pyramid, and that's going to help us with calculations later on. Because square pyramids and triangular pyramids have different bases. And next, it looks like we have a rectangular prism. One rectangular prism. And looking at the feet of this figure, I am seeing cylinders. I'm seeing 4 cylinders, and they are oblique. So 4 oblique cylinders. And it's important to note here that they have the same dimensions. It's going to make our calculations easier later on as well. Okay, so let's start from the top. We need to find the volumes of every single prism or figure in this diagram. So let's start with the pyramid. So the volume of any pyramid, doesn't matter what the base is, the volume of any pyramid is 1/3 times the area of the base times the height. And so I'm just going to redraw this pyramid to make things look a little clearer for us. And we've got a square base. Or as square as I can get it. There we go. And I know that the length and width of that pyramid are 16 inches. And the height of this pyramid, the height, it's kind of hidden behind one of the edges here, is 20 inches. So we are going to find that volume. I know that the area of a square, or the area of the base of this pyramid, is base times height, or length times width, and that's 16 times itself. So the area of the base is 16 times 16, and the height is 20. And when I calculate this, I get the volume to be about 1,706.67 cubic inches. So we found the volume of the head of that figure. So now we need to find the volume of the body of that figure, the rectangular prism. So in a different color, the volume of any prism is equal to area of the base times the height, or since this is a rectangular prism, it can be length times width times height. But either way, it's going to be, I've got the dimensions of 22 inches for the width, 15 inches for the height, 18 inches for the length. And since we are multiplying them together, the order does not matter. So the volume, after multiplying, is 5,940 cubic inches. So the last figures we need to find the volume for are these oblique cylinder legs. I'm going to redraw one of them. And when I find the volume of one, I am finding the volume of all four. So I know that the width of one of these legs, or one of these oblique cylinders, is 4 inches. And so that's telling me the diameter is 4 inches. So the radius is 2 inches. So the volume of any cylinder, whether it's oblique or not, sorry, I forgot the height here. The height of this cylinder is 16 inches. So the volume of any cylinder, oblique or not, is area of the base times height, or pi r squared times height. And since we have 4 of those same exact cylinders, we're going to take that formula and multiply it by 4. So volume equals 4 times pi times the radius, which is 2 squared, times the height, which is 16. And so with those calculations, I'm getting the volume of all 4 cylinders, all 4, not just one, to be 803.84 cubic inches. So when you have multiple figures with the same dimensions, you can find their volume without having to add up, for example, 4 cylinders worth of volume. All right, so we found the volume of the pyramid, the rectangular prism, and all 4 cylinders. We are ready to add those up to find the total volume of the figure. So the volume of the total is equal to the volume of the pyramid plus the volume of the rectangular prism plus the volume of the cylinders, all 4 of them. So that's going to be 1,706.67 cubic inches plus 5,940 cubic inches plus 803.84 cubic inches. And that total is 8,450.51 inches cubed. But we're not done. The problem was not asking us to find the volume of the sculpture. The problem was asking us to find how many bags of concrete mix will this person need to make the sculpture. So let's continue that on another slide. So looking back at this problem, each bag of concrete mix makes 0.6 cubic feet of concrete. So let me bring back our total volume, and that volume was 8,450.51 cubic inches. So I'm already seeing a conflict of units here. We have a volume in inches cubed. The problem is asking for feet cubed. So let's do a little unit conversion here. I know that 1 foot is equal to 12 inches. So now we need to find out cubic feet and its relation to cubic inches. So I know that 1 cubic foot is actually 12 cubed inches. So not just 12 cubic inches, but we're cubing 12. Big difference there. So when I take 12 and cube it, 1 cubic foot is actually equal to 1,728 cubic inches. Big difference between 12 and 12 cubed. So let's go ahead and take our volume measurement and convert it to cubic feet. And to do that, we're taking the total, and we're going to have to divide it by 1,728 to find cubic feet. And when I divide, I get about 4.89 cubic feet. So this is the measurement of the amount of concrete that the sculpture is going to use. But we're asked how many bags of concrete mix do we need. So that's entirely different. So to find the concrete mix the bags of concrete mix that we're going to need, we are going to take our total needed concrete, 4.89 cubic feet, and we need to divide it by the volume of the mix in each concrete mix bag, so 0.6 cubic feet. And so we're going to get about 8.15 bags. But you can't buy 1/1500ths of a bag. So our final answer here, we're going to have to round up. So Caitlin is going to need 9 bags of concrete mix because we rounded up. And there you go. That was a problem. Okay, so that was our lesson on the volume of composite figures. So just to review, composite figures are figures that can be divided into multiple basic figures like cylinders, cones, pyramids, spheres. And to find the volume of composite figures, we need to identify the basic figures and their dimensions. We're going to find the volume of each part, and we're going to add or subtract the volumes to find the volume of the whole figure. I hope this lesson was helpful to you, and I hope you have a great day. Thanks for watching.